My dear students, today we will discuss few more problems related to find out whether the following discrete time signals are discrete time systems are static or dynamic, linear or non-linear, shift invariant or shift variant, causal or non-causal, and stable or non-stable. Here they will give. I have in the notes I solved all these problems. Therefore, for your reference, I will discuss only one problem, one or two problem. The rest of the things you have to refer the notes. Therefore, here I will discuss one problem for our understanding how we'll find out the properties of a system, whether it is static or dynamic, linear, non-linear, shift invariant or shift variant, causal or non-causal, stable or unstable. Now, for example, we will take an example of a particular. This is y of n is equal to cos x of n. These are the problems related to discrete time systems. These are discrete time systems. Y of n equal to cos x of n. Today, this we will discuss. We will take this. This is the equation of a discrete time system. Then we'll find out whether the what are the properties of this system. Therefore, what we'll do here, first we'll take this problem, that is y of n. Here y of n equal to what? Cos x of n. Cos x of n. Now we'll determine the various properties of the system one by one. First we will find out whether the system is static or dynamic. Since a system is static, if its output depends upon the present input sample. Hence, y of n depends on the present input, since it is depending on cos of x of n, therefore the output is depending on the present input only. Therefore, this system is a static system. If it is depending on the previous inputs, that is x of n minus 1, x of n minus 2, suppose it is depending on the previous inputs, then at that time this system is not a static system. Then it becomes the dynamic system. But here you see the equation of a system, that is y of n equal to cos x of n. Therefore, it means that the output is depending on the present input. Therefore, this system is a static system. Here x of n is depending on present input, present sample. Therefore, the system is static system. Next, we'll find out whether system is linear or non-linear. To find out that one, first the same system we will consider as y of n, and we'll find out what is y of n. That is, equation is cos x of n. Here, since we are finding y of n, then y of n will represent the input as x1 of n. This is the equation y of n equal to cos x of n, but we will consider as this is yn of n equal to cos x1 of n for analysis of whether the system is linear or non-linear. For the same system equation, we will find out what is its y2n. y2 of n equal to apply the function, that is t x of t2 of n equal to cos input. Previously we have considered input as x1 of n. Now we will consider that same input as x cos x2 of n. Then apply the formula y3 of n. Here already I have discussed, that is the response of the system to the response of the system to linear combination of two inputs will be, that is y3n. How we have find out about the y3n, whether it is y3n is equal to y3 dash of y3 of t equal to y3 dash of t, whether it is equal to that one, then we consider that as a linear system. But here you see that one. Similarly, we will find out about y3 of n. y3 of n is nothing but, this is nothing but, it is function of a1 x1 of n plus a2 x2 of n. Here cos but here x1 1 x2 n, but here we'll take cos as common. Cos common, here function only we have to replace it by x of n as x1 n and x2 n. Therefore when we apply here, then y3 n will be equal to cos a1 x1 of n plus a2 x2 n. This is how the linear combination of two inputs will be. Then now we'll find out what that is y3 dash of n. That is equal to, this is the formula. Therefore to avoid confusion, I have written in a separate that is separately how we can find out that one. That is this is how, while discussing about the properties of linear system, that time we'll come to know how we can find out whether system is linear non-linear. If y3 dash y3 y of 3 y3 of y3 of t is equal to y3 dash of t, then this system is a linear system. In case of discrete, if y3 of n is equal to y3 dash of n, then this system is also linear system. This is applicable for dt system. This is applicable for ct system. If y3 of t is not equal to y3 dash of t, then such systems are we call as non-linear systems. Therefore, these are the equations. Already while discussing about the properties of linear, whether the system is linear or non-linear, at that time we have discussed about these equations. Go through the notes. In notes, I have written everything about this. Therefore, now we'll find out what is y of y3 dash of n. That is equal to a1 y of n, a1 yn of n plus a2 y2 n. Then it will be a1. What is y1? Y1 is what? Y1 is nothing but here. We have found out what is yn here. Yn equal to what? Cos x1 n. Therefore, y1 is equal to cos of x1 of n. Then a2 as it is. What is y2? Y2 is what? Cos x2 of n. a2. Then here a2 as it is, then y2 will be cos x2 of n. Then here what this equation, therefore from observing the equation of y3n, you observe this one y3n and this y3 dash of n, I think therefore these are then here you see that one both are not both y3 of n is not equal to y3 dash of n. Therefore, when they are not equal, then that system we call as nonlinear systems. If y3 of n is equal to y3 of dash of n, then such systems are called as linear systems. Okay. This is how we can find out whether the system is linear or not. Similarly, the system is said to be shift invariant or time invariant. If its characteristics, that is as they do not change with the shift in the if the system is said to be shift invariant or time invariant if its characteristics do not change with shift of time, or that means if there is shift in the input, corresponding there should be shift in the output, then such systems are called as time invariant. If there is no change, then such systems are called as time variant. Then y of n equal to tan x of n. For this, what we'll do, that is equal to cos x of n. Now we'll shift the input. Now let us delay or shift. We'll delay the input by k sample. That will be k sample. Then the output will be y of n that we call as y of n comma k equal to function of x n minus k. Here, therefore, what the input is what? Cos x of n minus k. Now what we'll do? Now we'll delay the output itself. That now let us delay the output y of n by k samples. That is y of n minus k. This is what y of n comma k. This we will call as y of n minus k. This is equivalent to replacing n by n minus k in the equation of y of n. Then y of n minus k equal to cos x of n minus k. You observe here, this is the your y of n minus k. This is the output, and this is up to output. This is for y of n minus k. Here there is no change. Here no change. Is there any change? No change. Therefore, above equation are say comparing above equation with the equation of, we observe that both are same. That is y of n comma k is equal to y of n minus k. Therefore, this system is time invariant system. This shows that the system is shift invariant, or also we can call as time invariant systems. That is about finding whether the system is time invariant or invariant. Next, one more property, that is whether it is causal or not. The system is said to be causal if its output depends upon past and present inputs only. That the output is given as y of n equal to cos n. Since it is depending on the present input, therefore this system we can call as causal system. Hence the system is causal system. System is causal system because it is depending on the present input only. When we call the system is non-causal if the output is depending on the future inputs. No, in reality such systems are not there. If even the in equations, suppose the output is depending on the future input, at that time that system we can call as non-causal systems. Here fifth property is what? For any bounded value of x of n, the cosine function has bounded value, hence the y of n has bounded values. Therefore, the system is called as stable system. Hence, system is said to be BIBO, stable. BIBO means what? That is bonded input, bonded output system. As long as the input is bonded, output is also bonded. Therefore, such systems are called as BIBO stable, or this is stable system. Thus, the following system, that is this system, is the whatever the given equation, the system is the properties of the system are this: it is static, non-linear, shift invariant, causal, and stable. These are the properties of this system. This system, whatever I have given. First one, that is y of n equal to cos x of n. They will give such equation and ask you to find out, check whether the systems are static or dynamic, linear or non-linear, shift invariant or invariant, causal or non-causal, stable or unstable. Like this, they will ask. Here, for your understanding purpose only, I am discussing only one problem. Here you see how many problems are there. Nearly 9 to 10 problems are there. Therefore, go through the notes. Same concepts will apply for to find out whether the system is causal, stable, or it is static, dynamic. Therefore, go through the notes to understand the other examples also. I am discussing this problem for understanding purpose. Therefore, the time is also less. Therefore, I am discussing here only one problem related to discrete time systems. How to find out whether what are the properties of a discrete time systems. Okay. Thank you.